Team Developer 7.3.3, multi-threading and REST web services. Explicit wrote down Team Developer 7.3.3 because we did during the last, or inside the last patch, we did a lot of things for the multi-threading area to start the threads much faster and quicker and get more information out of it and make it more usable. So at this point, if you want to run my application later on, my sample with Team Developer, please make sure that you have installed Team Developer 7.3.3. Okay, let's go into the agenda. I want to give you a brief overview about threading, how it is implemented into Team Developer, about some techniques inside Team Developer, some special features in Team Developer to make it pretty easy to implement threads inside your application. And we have also looked into the debugging feature. That means we have now more than one process running inside our IDE during debug time. And maybe we want to debug a special thread and we have to stop special other threads and so on. And we have to maybe to bring the main thread into a suspended mode. All things must be possible inside Team Developer, inside Team Developer IDE. Also, I want to give you a sample how to implement and how to use REST web services, or not REST web services also, but threading inside Team Developer. And you will see it's not really a big deal. So if you use my sample, if you change and copy paste this information into your application, and maybe you have a running functional class, and it is pretty simple to run this class with all these features and so on as a thread inside your application. And the next step is consuming REST web services. For that, I found a nice REST web service, which explains pretty well how the implementation is done in Team Developer. And also I use this web service, a REST web service inside my sample. So my background thread will run this web service, will get information out of the web, will display information later on if the thread is finished and so on. So maybe a useful sample for that, also for the REST web integration and usage of inside Team Developer, and also for the debugging and for the implementation stuff. What are threads? So threads is not new. It's a mechanism that process can run to run a code sequence in a parallel which eats others. That means you have a main application running. This main application, for example, is going to the database and has heavy load to the database and is doing a lot of things in the background. That means it's running and calculating something. During this time, the user interface is blocked because we have only one thread in my application, inside the application. And this application is used to run, for example, as a main application. That means the user is blocked to work with this application. So if you click into his screen, maybe into a column or into a combo box, then you get a gray application is not responding. That means the process is busy with some other stuff, like going to the database, like setting up a printer environment, like collecting information, setting up thousands of reports and so on. At this point, no one can work with this application. And in Team Developer in the past, it was only possible to have one thread running. And this thread was mainly responsible for the user interface, for all the event handlers and so on. And with Team Developer 7.3.3, it is now possible to have another thread running or more than one thread running, and it gets his own environment, environment to run and communicate with the backend. And there is definitely no mechanism to have an interaction between different threads. That means if you create a normal background thread inside Team Developer and the thread runs, you cannot directly touch it. You cannot send information into the thread by telling the thread, maybe give me some information, give me some data and so on. It's not possible. Also, if you run code inside a thread is not possible to interact directly with the user interface. That means also that you cannot, for example, pop up a message box or to ask the customer to do something or the user to do something. We have implemented a dispatcher, and this dispatcher is used as a mechanism to execute code back on the UI thread. That means we can have a small integration, a small transfer of data and information between the main process and the backend process. So the dispatcher is really used for the communication and to send in information into a thread or send some information out of the thread. You need a special user interface and API. Later on, I want to go into details of this API. And maybe if you have an existing part of your application and you want to bring it into a thread, then you have to discuss and you have to find out what's the right way to add special style functions in API function into the thread to get information out of the thread or pass information into the thread. Normally, working with threads can be very complicated. So if you look in Visual Studio, if you look into different other development environments, you will see working with threads is not very easy. And often low-level libraries are powerful and can advance user cases, but they are very difficult to use for common user interface tasks. And for Team Developer, it should be easy to use. Maybe there's one or two functions missing, but I'm pretty sure you can use it and easily implement that for most use cases. And we have a user event model similar to WPF for the communication between the background and the user interface thread. The keyword is the dispatcher. That means we have for events, and with this events, you can pass information into a thread and out of a thread. And of course, it should be easy to update the user interface on progress. That means maybe you want to inform the main application or the user at least inside the progress bar. 20% of the job is done, 50% of the job is done, or my process is finished, or there's an unexpected error inside my thread. So this information should be passed to the user interface. Benefits of Team Developer multithreading: works with Win32, Win64, and .NET compiler targets. So if you start looking into threads and you start implementing threads in Win32 applications, and after a while you want to compile to application to 64-bit, you can use the same code. There's no difference. The same for .NET compiler targets. That means the .NET compiler also supports all the events, the dispatcher, the information, and the style API, which is also available for Win32 and Win64. And the main key and the main advantage was to keep the application responsive when executing heavy processing tasks. That means a lot of things are running inside my backend. Maybe I'm connecting to a mail server. I want to collect all the information from the envelopes. I want to pass this information into my application. I want to store maybe the body and some information from the from this mail into a database and so on. So it's a heavy processing task inside a thread, but the user should still keep working with this application. So the application must be responsive. And user can continue to use this an application while background threads executing complex database operations, complex file I/O, fetching emails, going to the web, sending maybe documents over the web, collecting information from other systems, and so on. So it's very useful for very heavy loaded environments and heavy background usage. That means everything what is really time expensive. Please look into your profile viewer. So if you have, for example, a complex file I/O, it takes maybe 4 or 10 seconds, then it makes sense to look into background threads, how you can implement this information into a background thread so that the user is not blocked for the next 10 seconds. And of course, an easy team developer open object programming implementation. That means at least it should be OOP based, and existing classes should work inside this implementation with maybe only a few changes, and then it should be running very well and easy to debug. So what we have implemented is a background worker class. It's a new class type, and this class can inherit from functional classes for code reuse. So if you have, for example, a functional class, this functional class is dealing with emails or is dealing with a REST web service, then you can inherit this background worker class from the functional class. So at this point, the background worker class learns how to work with maybe with a REST web service. There must be a thread start outline section inside the background worker class. That means inside this thread start outline section, there is a code which should run in the separate thread. So if you have only one function, fine, you can call this function. If you have maybe an instance of a class with a lot of functions or running inside the class, then inside the thread start outline section of the background worker class, you should code this sequence of functions. Inside the form windows, MDI windows, and so on, you will find a new section to create this new background thread section. That means inside the background thread section, you will find a lot of information and all these events to work with this background thread. That means to prepare the thread, to get the finished result from the thread, the finished event from the thread. Maybe you want to pass inside the thread section, you want to pass the progress of this thread. And of course, if something went wrong, you want to track also the error. So you want to say to the user, hey, try it again because we had a problem, the network was down or whatever. So at least you have to run these instances in a thread by calling the new SAL API functions. So to run a thread is pretty simple. This is only one function, and you can start directly coding this function. And after this time, you get all this information from the thread. So implementation architecture is pretty simple. On the left-hand side, we have a form window or an MDI window, and we have a new section. This section is called background thread. And we create an instance of a background worker class. And at this point in the screenshot, we have two background workers. You can have maybe 20, 50, you can nest them, no problem at all. We have some events, like we want to have the report progress. We have an event error and finished on the main user interface thread. So we get information out of this thread. In the middle, we have the dispatcher. That means the dispatcher starts a thread, set all the informations into the thread, and we have the report progress, thread finished, and error. That means sending back information to the main process. So the dispatcher is a communication layer between the main thread and the background worker thread. And inside our background worker class, we have now some instance variables. We have maybe derived from a special class, and we have inside the thread start section, we have code. And this code is running in the background thread. In this case, this is only a set user, set database in some information and so on. It can also be methods from a derived form class and so on. So it's really high-level coding. There's no need to add at least or to change code, but after a while you will see, and if you look into the API, you will find out maybe it makes sense if you want to stop a special thread. You want to check if a thread is still running, because maybe you have a long running thread and this thread and the main application should stop. So an application exit event is raised. At this point, you have to check if there's still a thread running, a background thread running. If not, the application will tell you there's something running. Do you really want to close now and to stop your application? So implementing threads means you have to create a background worker class and add this background thread instance of the background worker class to desired window. Normally, you can use threads in a form window, in a dialog, and in an MDI window. I recommend to use background worker classes and instances of threads inside an MDI window. The reason for that is if you close a special MDI window, then you close normally the application. You get an application exit, and you can check before the exit runs if there's still a background worker running, if there's still a thread running, and you have to check it. Also, if you want to stop a special thread inside your application, then you have to clean up your application. But later on, we want to talk a little bit more about that. And from the window object, somewhere inside the window, you start your application, you start the background thread by using sal background worker start. And you have to pass in the object of the worker instance. And that's it. And then the thread starts, the dispatcher starts, and everything is fine. And the dispatcher tells you the application and the thread is started, the values are set, and you can wait and still wait. Maybe if the thread responds some report progress, or what you can do is you can work still with your application. And this is most common, I guess. Thread class definition. If we look into the thread worker class, background worker class, is normal, I guess, the same features like in a normal functional class, excepting that you have an event or a node called thread start. And inside the thread start section, you write all the code inside the actions, which should run inside this thread, like long-running database actions, long-running .NET reports, and so on and so on. But no GUI interaction is allowed. It's not possible. You cannot directly write something in the data field. You cannot directly access a grid to write information into a grid and so on. The only way is to use global variables or to use instance variables of your functional class and arrays and so on of objects and pass them back to the front end. And if the event thread finish is raised, then you have to read all this and map all this information into the front end, into the GUI. So it's not possible to write something directly into the front end. It's not possible. At least you need an inside, like a form window, you need inside the new section background threads, an instance of a special thread worker class. So it gets a name, and after that you get the thread event section. So we have 4 of them: thread before start, thread report progress, thread report error, and thread finished. You don't need all of them if you don't want to track errors. If you don't want to track the progress, then start and maybe finished is okay. It's fine. It's good enough. But at least if you start sal background worker start with this instance, like this object, you pass the object as a parameter, then the event before start is raised. And then you can, inside the event, you can prepare your background thread and so on, set all the instance variables as for an input, and. So after that, if the last line of this code is done, then the thread starts. So thread before start, thread code only starts after the event returns. So put your installation code here. That means you can set up all the instance variables, you can set up all the settings for the thread or all the information what is needed to run the thread. It's a synchronous event. That means the thread starts after the last statement inside this section. Thread report progress. This is, inside this event, you get back information from the side background worker report progress. This is a function which runs inside the thread. So you can code, I want to send back 20% and a message file open. So this information is sent to the main thread, to the GUI, and you can, for example, bring a progress bar up to date to bring out a message in the task area of your MDI window, and. So it's an asynchronous event. That means the thread is running, but maybe the front end cannot show the information because the main event is busy. But it's inside the queue. So it's not lost, it's really inside the queue. And after a while, if maybe the user interface is idle, then the information is displayed. Thread finished is raised when the thread code has finished execution. That means the thread is done. It returns true, for example, all the information is done, all the work is done in the background. And then inside the thread finished section, you can now map all this information, bring them into the user interface, populate the combo boxes, get information maybe from the customer side into the front end and so on. It's also synchronous. That means if the user interface is idle, it's still in the queue. So if there's idle time inside the front end, the user is waiting for something and so on, then this is published into and is brought into the front end. Thread error is raised when an unhandled error is thrown by the thread. So it's important not to show a dialog because it's not allowed. You cannot compile it, so you get an error. But if the section is coded, then maybe you can give some information in the thread error section. At this point, you can code, well, there's something wrong. Bring maybe a red color into the progress bar. Give some information out. So it's also an asynchronous event. That means it is only raised, and you can see the information if the front end is idle. So is the front end busy? You will not see that. It's buffered again. And after a while, if the user interface is idle, you will see all this information. Thread before start, here's a small sample. So at this point, for this event object CSV file, we have the thread events, thread before start. We have an action, set, an instance variable with this nice text. That means we prepare the object inside the thread, so the instance variables. After this line, the last line inside this action section, the thread will start. Not before. So it's a synchronous event. Report progress means the event, the thread, sends out some information about the progress, and you get back this information inside the event parameter. So they're predefined, the progress, number of progress, and the string. And maybe you have a list box or you have a progress bar or whatever. So you can use this information to populate, for example, a progress bar. But again, you have to calculate some information and you have to bring it back into the main thread. Thread finished. So this event runs if the thread reports, I'm done, I'm coming back with true, everything is fine. Then at least the thread is finished, and then you can, for example, pass all the information from the thread, all the instance variables to the front end or into the reports and so on. Enable buttons, retrieve process data. A lot of things can be done. One important thing is if you have an unhandled error, that means something happens with this thread. So it comes back and there was really thrown, an error was thrown and so on. Then the thread finish is not raised. So at least it's pretty safe. You cannot display incorrect data and so on. If there's an unhandled error, please track this on error event. thread error. Again, gives back some information about an error number and the string. And of course, you can set back information like a SQL error, strings, and so on. And if called, if something happens, if something comes back in the thread error section, then the finish event is not called. So it's not displayed some information like it was successful if it was not successful. And let's have a look into the API. We have background worker start with my object of my worker inside my MDI form, for example, and this is used inside the main application. So that starts immediately the thread. It looks into the before start event and initialize all this event variables, instance variables, and so on. And after that, the background worker starts. Background worker report progress with 2 parameters is used inside a thread. That means the thread sends back information about the progress and maybe or a message. Background worker is busy. It's used inside the main application to check if there's still a special or indicated background worker is still running. And you can use background worker cancel to cancel background thread. So this is sent to the background thread, but the background thread is not stopped. It's not canceled. It's only a flag. To stop a background worker cancel or a background worker, then you have to use background worker is canceled inside the thread. So maybe if you have a loop, you are collecting data from the database, you're calculating some things and so on inside the loop, then you have to check inside the loop, maybe one time at the startup of a loop, background worker is canceled. If this flag is true, that means the main application sent worker cancel for this thread. Then you have to clean up your thread. That means maybe you have to roll back the database. You have to close all these files. You have to do a lot of things to clean up really your background data. You have to maybe reset all the instance variables and so on. And then you can close the thread. You can go back. And background worker any running means maybe you have an MDI window, you have maybe 2 or 4 or 10 threads running inside the application, and sometimes long running threads. Then it makes sense to raise or to use background worker any running inside your main application before you stop working with your application, before you stop your application, you end your application, exit your application. That means this one checks if there's any background thread running, but you have to pass in the handle of the window. Therefore, what I did in main application or in some custom application, I use the multi-threading environment inside an MDI window because the MDI window was mostly the main window of the application with a ribbon bar, and the user want to end the application, to exit the application, and before we raise exit, we check if there is a worker running in the background. And if there's some running, then we can check which one is running with worker is busy. And if we find them, we can directly send in a worker canceled if needed. If it is important that the application should still run, then we should stop the exit sequence. That means the application must be active. Here's some details again about the Cell API. I don't want to go into deep details because we have talked about that previously. So at Lifecycle, at least we start running a background thread by using the thread start event. That means this is synchronously. We set all these environment variables, instance variables to run the thread. All the information which are needed from the thread are set. And then we do the execution of the thread. Inside this information, we have maybe a dispatcher running, and we check if something happens inside the thread. If we have a progress, this information is passed to the front end. Is an asynchronous process because at least if the front end is busy, then maybe the finish is not raised or a progress is not raised until the user interface is idle. Then we get the information, and if the process is near the end, that means we do a return from this background thread. We get the error or the finish event, and then we have the complete completion. That means at this point we no longer have this event and the process IDs and so on. Thread debugging. We have a new debug window. It's called thread windows. And if you look into this debug windows, you will see a list of all running thread IDs. So all the process IDs for your application. And maybe you can have more than one breakpoint. You can have more than one active line. And you can see we have different colors to display different threads. Like you can bring a thread into a suspended mode. You can have a thread in a debug mode. And maybe the main application is still running. Or you can do a right click and say, okay, I stop my main application because it's still asking for a progress or whatever. So I can bring it into a suspended mode. And I can click on the C object CS file on this thread event and can say, okay, I want to debug this one now. And you will be placed into the right line, into the thread. And then you can debug, for example, the CS file object. And if you want to stop debugging that one, you can bring it into run mode. So there's no breakpoint at least. Then the application is running. And after a while, maybe a finish is raised. Or you can also stop it, bring it in a suspended mode. So at least there are a lot of options, and it's sometimes not very easy to debug threads. But if you want to debug simple code, if you want to look if the code is running very well, if every variable is set and so on, then it makes sense to set a breakpoint into the thread. And you will automatically see the right local variables. You see all the class informations and so on. If you go into the main thread, then it will automatically change the content of all the related debug windows. So again, this is a pop-up menu to continue, to step in, to step over a thread, to select something, to bring it into the debug mode. So at this point, the main thread is suspended, the invoice thread is suspended, and we are debugging now the CSV file. So we are now in the code section of this object. Before we look into the implementation and we look into the source code, I want to have also a look into the REST web service wizard to give, because my sample is based on the REST web service integration, and this REST web service is running as a thread. So I can show it easily inside the code how that works. So in the past, before we started providing a wizard, a REST wizard, you had to type in a functional class with all the instance variables, and it must be very, very accurate. Because if you have a typo in, like you have a capital letter and it was not used as a capital letter in the original web service and so on, the web service will not work correctly. So the web service wizard is pretty simple to use. At least it saves you 98% of coding. What you have to do is pretty simple. Start this web service wizard, type in the REST URL or the JSON string, and it looks directly into the web service itself and gives you all the instance variables, like the strings. Also, if this is an array, so you see all this information in the definition. Also, what you can see is nested informations. Like there's another class inside. So a nested class maybe to contain more information. And all this information with the right data type and so on is then, after running this wizard, is built into an APL. And this APL can be loaded into the Team Developer code. And after this point, the REST web service should work without any problem. So at least you have only to code to set instance variable, to use a SAL JSON, deserialize, serialize functions, and then you get back the information, and you can directly pass this information to your front end. Or if you want to pass in information into the web, then you can use directly SAL serialize to pass in information to the web. So it's very, very simple to use, and you don't have to take care about complex data types and so on, like in SOAP. Then you need at least complex data types. You have to deal with a number. You have to use decimals and so on. So it's not needed if you are using this REST web service integration. The REST implementation, the wizard selects the JSON structure from the URL or from the JSON string. And then you get all this information as instance variables inside an APL. So what we are creating is functional classes, and the main class is always the root class. The root class is also instantiating additional functional classes if needed. So if, for example, you want to work with the whole web service, then it makes sense to create an instance of the JSON root class JSON root. Then everything is inside the class, and you can use the full class, all the instance variables, all the arrays, all the complex data types inside the web service, and you can directly map them into data fields or into other information from other classes and so on. So you can also derive information directly into a web service. Here a small sample, and later on I want to show the sample. We have a local variable inside my dialog or inside my form is my JSON root. So previously, remember, this is my main class JSON root. So I create an object based on this JSON class root. I have my error because my function to work, my serialize, deserialize function works with this error, needs this error information as a receive string, and also maybe I have to pass in the user and a password because maybe it's protected. We have also a SAL JSON deserialize UDVX with some additional parameters like two arrays to pass in additional information to the web service. If the web service needs more information like authentication, like special nodes and so on. So it can be passed in with different additional parameters. So at least the application itself or the function call is very, very simple. The first parameter is the name of the instance of the web service, not the object they want to have at this point. Is needed to pass in the name of the object. Then this is a URL. What should be done? That is the combination from the method of the web service and maybe a value. At this point, if you look at this combo box, we have a method name and the value Canada. So we pass this URL, HTTPS, and so on into the UDV, into the serialize JSON function. We pass in the user and password. At this point, it's empty, it's a string null. And we receive an error. If there is an error, it happens. What we get, we have to check if there's an error. Nothing happens. And then we can directly start using the instance variable from, for example, the capital region, sub-region, and so on. You can directly map them to the data field or to another instance variable to whatever you want to do at this point, or to bring it into a table and so on. Also, if we have an array of objects or array of information like complex data, we get an array back like the borders, and we can count with upper bound the number of the borders, and we can bring them into a list box. So it's a pretty simple technology. It's not very special. There's no special coding needed to work with web services. And for the users, it's transparent. It could also be at least a call of a function or of at least, a functional call or a functional class call to do something with the database to fill this object. So there's no need to do something very special. Another sample, for the capital, we want to have the method capital, and we pass in the value Berlin, and we get inside the combo URL, we pass in the information with a string, so URL, and then we get back information from Berlin. See also cell.json deserialize UDX, and deserialize UDVX, that means with additional information if the REST service needs additional authentication. So the best point is always look into the documentation of the web service, and you get immediately information what is really used to run this web service. At this point, this sample is using an open web service, so there's no need to pass in additional information like user and password. Always a good point, see the documentation. So let's have a look into the demo. I open my application. At least what I have done, I have created a nice front end. I have a combo box URL. I have hard-coded some information, some URLs, because I don't want to type them in. I have a button, and this button is nothing else doing like call web service JSON and enable whatever a push button. This is a local function, and this function is always running if I click on this button. So this is only for testing my web service. So if I run my web service, if I click on that one, I set my user and password to string null. I clear my list. I do a serialize UDV with all this information, and I get back some information, and I pass this information, of course, into the different objects, child objects. So this is a local function. If I start my application and I choose one of this information REST, it's working very well. And also I can see the flag. It's, by the way, a WPF control. So fine. So far, so good. My thread is running, and not my thread, my function is running. But maybe this web service takes some time, maybe 2 minutes, 3 minutes, 20 seconds, and so on. Then my front end is not responsible. That means at this point, I'm sitting in front of my computer, I'm waiting. So I cannot do something, it's not responsive. What I have done is I created worker REST with a function, get REST data. The same, nothing very special. Only that I have some additional functions inside, like child background worker report progress. 100% maybe thread finished. Here 99 working with arrays and so on. So passing information from the thread to the front end. That's it. Nothing very special. Inside my REST web service derived from my original class, my functional class. So at this point, inside my thread start, I can call the function fget web service data from this class. So this is now running inside a thread. If I look into my front end, I can go into my background threads. Background thread, I created an instance of my worker class called OREST. Has some thread events. Before start, actions, do something. That means, for example, clear all the lists. This is done before the web service or the REST web service starts, and of course before the thread starts. My report progress comes back with a data field info, number info, bring in the progress and the string of the progress, which is called and erased from the thread itself. Report error. Okay, message box, something went wrong. Maybe the network is down and so on. And thread finished. Bring all this information from the background thread, from the instance variables of the class into the front end. Let's run the same application as a thread. Starts a thread, starts application, and normally this application is running with a timer. So we have now to wait additional 3.5 minutes. So what I can do is I can start the thread manually, and you can see thread finished. It's a very short thread, but at least you can see in my button, if I look into the button, I do the same as inside the timer. I say call style background worker start for the REST web server or REST background thread. And the timer does the same. So there's an event for the timer. On timer does really the same. That's working with background threads. So it's not a big deal. You have only to think about what's going on if a thread is really canceled. So if you send in the information, please cancel. This is only a flag, and then you have to clean up all this background information, reset the database, do a rollback, close all the files, and so on, clean up the thread. Maybe that's more complex than us working with directly with threads. So it's not a big deal. Okay. Any question?
Yeah, thank you, Helmut. There are a couple of questions for you. Some I think you have answered during the presentation, but we get to them again. So the first one for you is, does a thread stop when an error has occurred and an error event is raised?
Yes, it is stopped.
Okay. Quick one, the next one. How is the best practice to stop a thread from outside the thread?
Well, the best is to say cancel the thread with a and then the flag is set inside the thread, and you have to track inside the thread if it is canceled, if the flag is set. So there are two API functions. First one sends this information to the thread, and the thread maybe inside the loop tracks always this flag. So if the flag is set to true, then you have to code, please clean up my background thread. Maybe you have to do all this cleanup of the database and so on, close all the files, reset all the instance variables and so on. This must be done by yourself, by the developer.
Okay, next one. Is it also possible to send information to a running thread, not only receiving?
Well, well, yes and no. First of all, there's no direct way like an event to send something in or by using the dispatcher to send something in. But the thread can read global variables. So maybe a global variable is changed, and inside the thread, there's code to check this variable. And the variable, for example, is checked, and you want to pass to another database, or you want to exit the loop, whatever, that it can be done. But again, it's asynchronous, and maybe you set maybe a global variable at this point, but the thread reads this global variable much later. So there's definitely a delay and so on. So it's not possible to do something directly. But using global variables should work, yes. And also what you can do, you can set global variables outside from a thread. That means the thread knows about globals. So inside the memory. So if you want to set information inside the thread into global variables, that's also possible.
Okay, thank you. Next one, is it possible to create a PDF document in a thread with style report print to file?
Wow, that's a good question, because at least the reporting cannot be run as a thread itself. So at least you have no interaction with the front end. So, for example, if you create a report, then you want to save this report into a file. I don't think it works with the report builder, because report builder is bound to a special form window. And at this point, you have no way to find this information from the form, because you're not allowed and you're not able to deal directly with the user interface. So I would say no. But tomorrow I will maybe show something what you can do at this point.
Okay, very good. And then the last one for you. Can you run code generated by the .NET Explorer inside a background thread?
.NET Explorer. Yes, because the .NET Explorer is thread safe. So the .NET code is also thread safe, hopefully thread safe. It depends definitely on the .NET assembly. So if everything is proper developed and so on, then it is thread safe, and it should run also in the separate thread. Yes, should work.
Okay, thank you, Helmut.